Hello everybody, today I am going to teach you about the ninth lab program, that is to find the sine of x using the Taylor series. So the question is like this: develop a program to compute sine of x using Taylor series approximation, and then compare your results with the built-in library function. Print both the results with appropriate messages. Okay, so here the sine series is like this: sine of x is equal to, it will be like this, x divided by 1 factorial minus x power 3 divided by 3 factorial plus x power 5 divided by 5 factorial minus x power 7 divided by factorial. One thing you can observe in this series, that the power of x is odd, or we can say the power of x each time it is differing by 2, right? It is going to differ by 2. And same way in the denominator also you can observe factorial 1, factorial 3, factorial 5. Each number is getting differed by 2 difference, right? And then one more thing also you can see here, that alternate terms is minus plus. Here plus minus plus minus plus minus and so on. So keeping these things in mind, we can just try to write the code. So first we are going to enter the input in terms of degrees. Okay, what the input we are going to enter will be there in degree. We have to convert it into radians. Okay, we have to convert it into radians. So how to convert it into radians? So say x is 1 radian. How to convert it? So degree whatever you take, if you multiply it by pi divided by 180, I will get you the radians. Okay, so this is the formula to find the radians, that is degree into pi by 185 to get. So now how to find this series, how to write the code for it. So let us observe the first term. Let us tell this as term. It comprises of numerator and denominator. So let me initialize my numerator first time as x. Okay, x, and denominator by 1. Okay, denominator by 1. Next, so I can get my term, first term, by what? Numerator divided by denominator, that is x divided by 1 factorial. 1 is just nothing but 1 factorial is nothing but 1. So I can get the first term, numerator divided by denominator, that is x divided by 1 I get. Now how to prepare my numerator for the next term? I have to get x cube. So x cube how can I get? I can get it by x already it is there. I have to multiply 2 times x again. So I can tell my numerator is nothing but the previous numerator. Each time you can see the difference is 2, no? So into x, whatever previous numerator I get, into x, 2 times multiply x, I will get the numerator. And one thing you can observe here, minus is there. So what I can do it is, I can put a minus here. Okay, so I will get the term minus numerator into x. So this I got minus x cube by x cube, that is numerator. How to get denominator? Again same way, denominator, okay, 3 factorial I have to get. So 3 factorial is nothing but 1 into 2 into 3 will give me 3 factorial. So 1 I will get it by denominator. So multiply by 2. So I can take one more variable as I, and I can initialize it to 2. So how to get 3? 3 I can get it by telling I plus 1. So this is nothing but denominator is 1 and I value, that is 2, and I plus 1, 2 plus 1, that is 3. So I will get factorial 3. So I can write it as into I plus 1. Okay. So now what I got it is minus x cube by 3 factorial. So how to keep on adding this as a series? So what I can do it is, I can just write something called as variable sum, where I can initialize my sum to 0 and sum is previously 0, I can just write the term. Okay, so first time it is numerated by denominator, so x by 1 will be taken, x by 1 computation plus 0 the result. Okay, so each time I have to keep repeating these steps. Next time I have to prepare my numerator and denominator. I have done this here. Again compute numerator divided by denominator, the next term, that is x power 3 by 3 factorial. So I have to keep doing this. So I can repeat the steps by using the looping construct. So I can use any looping construct and try to repeat this. Okay, so this negative we have got here. So next time x power 5, I am going to get x power 5. Previous numerator is minus x power 3 is there, previous numerator, into x if I do. It is what already in my I have my term as minus here. So minus into minus plus x power 3 it will become into x. So plus x power 5 I am going to get. Okay. So same way 5 factorial I can get it by denominator into I plus 1. Okay. So denominator previously it is 3 factorial into I is nothing but I can increment my I plus 2. Each time it is differing by 2. So I am just telling I plus 2. So it is be 3 factorial into 2 into 2 plus this is 4. 4 plus 1, that is nothing but 5. So 3 factorial into 4 into 5. It is 2 plus 2, it is 4. So it is become 3 factorial into 4 into 5. So we can find the factorial 5. So this is how we find 5 factorial, and then I can just also write it as I is equal to I plus 2. So all these steps need to be repeating. So I can put it in a do while loop. Okay. For this I have to write a condition. So I can tell till the term is greater than or equal to 0.000001 approximation. So for do while loop you have to put a semicolon. Since the term can be in a negative thing, so we can write it as floating point absolute. So what does this floating point absolute do? I have explained you in the quadratic equation program, right? Absolute gives only the value of it. Since it is floating point, it will take only the value, floating point value, and not the negative symbol of it. Okay. So we put it in a do while loop all this stage. Now let us see how to write the program. Okay. So to write the program, we can start with #include stdio.h. This is for standard input and output, printf and scanf. Next, since they said we have to compare it with built-in function, so we can make use of mat.h. Okay, and then I am using the value of pi. I can define the value of pi. Okay, define pi 3.142, or else you can directly also use it. Writing void main function. Return type is void, that means it is not going to return anything to the system. So I'm going to have my input, that is degree. Okay, and one more variable I am going to make use of it. And as I see in my explanation, I have said you these are the terms which I am going to use. That is variables can be term, numerator, denominator, sum. So let us declare all these things as float. Okay, so I can just declare x, numerator, denominator I require, then the term I can get, then the sum computation, so I can initialize it to 0. Okay, next we have to enter the degrees. So printf enter the degree or value of the degree, I can say enter the value of degree. Okay, so using scanf, going to read degree. I have declared it as int, so %d ampersand degree. Okay, now what is the next step? We have to convert it into radians. How to convert it into radians? Degree into pi by 100. Degree into pi by 180 will give you the radians. Now first time I am initializing my numerator, so it is nothing but x. Okay, denominator is 1 factorial. 1 factorial is nothing but 1, and initially let the value of I be 2. You know that whenever we are using while or do while loop, the variable has to be initialized before itself, right? So I have initialized it to 2. So write this do while loop. Okay, so do. Okay, what is the first thing? See, my numerator and denominator are ready, so I am going to get my first term, that is numerator divided by denominator is my first term. So next time I have to prepare my numerator, that is minus x power 3. So how to do it? That is nothing but numerator is equal to minus numerator into x. If I do, I will get the numerator, and then denominator, how I am going to get? The previous denominator is 1 factorial into, I have to put I am initialized to 2, so 2 into I plus 1. If I do, it will become 3. So 1 into 2 into 3. Okay, put a semicolon. Now compute the sum. Okay, previously sum is 0 plus what we have to term, the first term will be added. Okay, and then each time I can increment to by 2. Since I said you the difference is 3, 5 and 7, the difference is 2, we are going to increment I by 2. So I am writing I plus 2. Okay, so these things should be happen inside while loop. So I am going to write condition as floating point absolute of term is greater than or equal to until it becomes some approximately till this approximation. Keep on doing. Next I have to print what? The inbuilt value and what I have computed the value, right? So to do that, use printf is sine of this number is this much. So after 3 digits we are going to display. Okay, so where are we going to get the number? That is our input degree, and then what the computation results, where are we going to get my sine series? In this sum. It is not in a term, but all the added things, term one by one we have added and kept it in sum. So it is available in sum, so I have to write it as sum. Okay, close it, put it. Now let us compare it with inbuilt function, because they have asked to print both the results. Okay, so say sine using built-in function for this degree is this much. Okay, now this is degree and this is using inbuilt function, so called sine of x. It is just sin, not sine, sin of x. Close the bracket, put a semicolon, close the main function. Okay, so this is your program, right? So these are the things we have to do. It's very simple, students. Just remember to prepare the numerator and denominator. First time numerator is just x, okay, as you have only x there, and denominator is 1 factorial. How to prepare the numerator for the next one? It is minus the previous numerator and multiply it 2 times x. How to prepare the denominator? Previous denominator into I plus 1 will give you the denominator. Okay, fine. So these things you are supposed to do. Okay, thank you.